Hello and welcome to this learning video. In this learning video, we are going to start with the Rayleigh Ritz method. So, let me tell you first of all the importance of Rayleigh Ritz method. So, the importance are number one, the Rayleigh Ritz method is very useful in getting the approximate solution to the boundary value problem. The second importance is to find solution of such functional for which the Euler's equation does not give the exact solution. And third one, which is the rare but the important one, to get the smallest eigenvalue for the given problem that can be done with the help of Rayleigh Ritz method. Okay, so let us see what is this method is all about. So you'll be having a differential equation of the type like this with boundary conditions. Then with the help of these this equation and with this equation, we have to construct a functional I by x, which is this. Now you may be wondering what are these p, q and r. So these p, q, r are the unknowns that we have to find out while solving the problems by these formulas. Once you get these p, q, r, substitute the values here in this, you will get a functional. Okay. This completes the step number 1. Actually, we are talking about the working rule. So, this is the step 1. In the step 2, what we are going to do is, we are going to approximate the solution. Okay. So, we'll approximate y using this, where all these phi x are the linear independent functions of x and phi 1 of x satisfies the boundary condition. So, I have to take phi 1 of x in such a way that this must satisfy these boundary conditions. Okay? And all the other phi's are vanishes at boundary points. That is my step number 2. Step number 3 says, put these values of y in the functional and find ci's using del ci1 by del ci of I is equal to 0. So if step 1 and 2 is clear to you, step number 3 says whatever y you have found out, and after applying the boundary condition, will be getting the values of some constant. So what you have to do is, you just have to substitute this value of y in the given functional. The moment you substitute the value of y in the given functional, will be getting I by x. Okay, and whatever constant is appearing in this I by x, so that constant value of that constant can be easily gettable by differentiating this with respect to that constant. Suppose this is my I by x after integration and this involves c1. So what I will do is, I will be solving this integral, then we will be getting I by x, and then I will differentiate this with respect to c1 and equate it to 0 to get the value of c1. Simple. Now when we solve the problems, you will find it very easy. Here we are taking the general case, so you may find it difficult. And once you get that ci, so what you are going to do is, after getting the values of constant ci, put it in this equation to get the required solution. Okay. So to make the idea more clear, let me take a problem on this, a simple problem. Anyway, the problem on this topic is very simple. So this is solve example. Solve y double dash minus y plus x is equal to 0. Boundary conditions are given. Y of 0 equal to 0 equal to y of 1 by Rayleigh Ritz method. By Rayleigh Ritz method. Sometimes in short it is written as RR method. Okay. Now look at this problem. Here, if you consider, this is my working rule with 4 steps. Now if you compare this given equation with this, what you can say, we have the value of ax to be 1. We don't have a term of y dash, means its coefficient is 0. This is 1, this is 0. Then coefficient of y is -1, so cx is -1. And when you take this to the right, so f of x would be -x. Is it? x1 is 0, y1 is 0, x2 is 1, y2 is 0. Okay, so we are going to start like this. If you want, you can write the given equation is this, and then you can continue. So let me write it as solution given this, on comparing with what was that, a of x y double dash plus b of x into y dash plus c of x into y is equal to f of x. In the given, I can write y double dash minus y is equal to minus x. Okay, so what is my a? My a is 1, b is 0, c is -1, and f of x is equal to minus x. Okay, then to construct a functional, I will find out this p, q, and r. On comparing with this, we get a is equal to 1, b is equal to 0, c is equal to -1, and f of x is equal to minus x. And f of x is equal to minus x. Now we find one by one all this thing. Okay, so let us find out this. So p of x is equal to this, which is e to the power integration of b is 0, a is 1, so 0 by 1 dx, that is 0. Integration of 0 is 0, so this is e to the power 0, this is 1. So I am getting p of x to be 1. Now, what is q of x? Q of x is minus c by p of x. What is c? C is -1, so this is minus of -1 upon a, that's 1 into p of x 1. So this again comes out to be 1. Okay, now what is r of x? R of x is 2 into f of x. F of x is minus x upon a is 1, p is 1. So this is minus 2x. So I am getting p, q, and r. Okay, now once you get this p, q, r, you can construct a functional. Therefore, the functional, what is that? Therefore, the functional I y of x is equal to what is it? Integration x1 to x2. So it is x1 is 0, x2 is 1. Integration 0 to 1. What is that? P of x into y dash square. P of x is 1, so this would be just 1 into y dash square plus q of x 1 into y square, yes, plus r of x. What is r of x? Minus 2x. R of x into y. So r of x is minus 2x into y dx. Now I have got the functional. Okay, and say this is to be my equation number 1. So step number 1 clear. We have written the given equation. We have compared with the general one. Find out the values of a, b, c and function, and sequentially you can find out PQR and construct a functional. So it is done. Now what is the second step? In second step we have to approximate y. So let y is equal to, we have to approximate the solution, C0 plus C1x plus C2 x square. This is my approximate solution. Okay, now you have this solution, approximate solution, so apply the conditions. Therefore y of 0 is equal to 0 implies 0 C0 plus C1 into 0 C2 into 0. So that is, I am getting C0 to be 0. So C0 to be 0. Next, apply the second condition. Y of 1 is equal to 0 implies y of 1 is equal to 0. Okay, so y of 1 is equal to 0. So 0 is equal to C0 is 0. C1 into 1 plus C2 into 1 square is 1. This implies C1 plus C2 is equal to 0. So you can write this one as C2 is equal to, that is C2 is equal to minus of C1. Okay, now after getting these values you have to substitute over here. Therefore y of x is equal to, y of x is equal to, what is my C0? 0. What is C1? C1 x plus, what is C2? C2 is minus of C1. So this is minus of C1 x square. So here, from here you can just common out like y of x, common out C1x, so you can write C1x 1 minus x. So this is my y of x, and from this y of x I have to take phi 1 of x. Phi 1 of x is equal to x into 1 minus x. So I am taking phi 1 of x as x into 1 minus x. You can check whether the boundary condition satisfied by this phi 1 or not. So it is like 0 0. So if I substitute x equal to 0, phi 1 of x is 0, and if I put x is equal to 1, so y should be 0. So 1 minus 1 0, phi 1 of 0. So this satisfies the boundary condition. Okay, now after getting this, say this is to be my equation number 2. Okay, now after getting this y of x, what you need to do is you just need to substitute this value in equation 1. Equation 1 becomes, so what does it becomes? I of yx, or you can write direct I is equal to integration 0 to 1 y dash square. So what would be its derivative? Yes, c1 minus 2 c1x. Okay, that's the derivative of this. It's a square. Okay, plus y square. What is y square? This c1 square x square 1 minus x square. Is it? Yeah. Minus 2. What is 2x? What is y? Y is again c1x into 1 minus x and dx. Now we have this. Okay, you can just solve all these things, and then you can separate the integration and solve the and try to apply the integration and apply the limits. Okay, so let me first of all write this one as I is equal to integration 0 to 1, then it is c1. So I can take c1 square common throughout, so it is like c1 square outside, integration 0 to 1 1 minus 2x whole square dx. I am separating the integration here also. C1 square outside, integration 0 to 1 x square into 1 minus x whole square dx. Minus here again C1 square. I can take 2 C1 square outside. It's 2C1. It's 2C1. Integration 0 to 1 x square minus x cube dx. Let me check once. Is it x square? Yeah, minus 2C1. Okay. So now you can just integrate. So this is like C1 square. What about this? You can expand this first and then you can take integration 0 to 1. 1 minus 4x plus 4x square, it's integration, plus C1 square, and then integration 0 to 1, this is 1, so x square minus 2x, so this is 2x cube plus x square square x power 4 dx minus 2c1 integration 0 to 1 x square minus x cube dx. Okay, so I is equal to c1 square. What is integration of 1 x minus 4x square by 2 plus 4x cube by 3, 0 to 1 plus c1 square. What about this? This is x square. So this is x cube by 3 minus 2x to the power 4 by 4 plus x to the power 5 by 5 minus 2c1 into x square by x cube by 3 minus x to the power 4 by 4, 0 to 1. Okay, lower limit is 0, so it won't contribute to anything, but upper limit will contribute. So this is c1 square 1 minus 2 plus 4 by 3 plus c1 square, this is 1 by 3 minus 1 by 2 plus 1 by 5 minus 2c1. What about this? X cube. So this is 1 by 3 minus 1 by 4. So the moment you solve this, you'll be getting I is equal to, what is it? Minus 1 plus 4 by 3. So minus 3 plus 4. So this is 1 by 3. So 1 by 3 c1 square plus what about this? This is minus 1 by 6 plus 1 by 5. So minus 5 plus 6, 1 by 30. So this is 1 by 30 c1 square, and at last we'll be getting 2c1. So this is 2c1, this is 4 minus 3, 1 by 12. So this get cancelled with this 2. 1 by 12. Okay, now you can solve this and you will get I is equal to, from this c1 square. Okay, c1 square, solve this, 30 plus 11, 33 by 90. So this is 11 by 30 c1 square minus 1 by 6 c1. So I am getting this I, 11 by 30 c1 square minus 1 by 6. Now as you can see that we have to find out the value of constant c1, and that can be found out according to the working rule, that can be found out by differentiating this with respect to, you can differentiate this with respect to C1. Therefore, del I by del C1 is equal to, what is it? 2C1 into 11 by 30 minus 1 by 6. So, equating this to 0, now you can write actually del C, let me write, to find C1, del I by del C1 is equal to 0. And what is del C1? Del C1 is 2C1 into 11 by 30 minus 1 by 6 is equal to 0. Okay, so what is C1? So this implies 11C1 is equal to 1 by 6. Okay, so C1 comes out to be, this is 11, this is 6 2 za, this is 5 za, so 5 by 22. So C1 is 5 by 22. Now once you get this, you can put this value in equation 2. Put this value in equation 2, we get, what we get? We was having y of x as, what is that? C1 x into 1 minus x. So 5 by 22 x into 1 minus x. This is the required solution. This is the required solution. So I hope this method is clear to you. So I want you to solve one problem. So I am giving you one problem on this method. So you just try to solve this method, which is example solve. What was that? Y double dash is equal to 1. Y of 0 0 equal to y of 1 by RR method. So this is a problem for practice, so you can try this at home. So thank you for watching this learning video and enjoy learning mathematics. Thank you.